I've got this electronic kit that I want to build. It is an electronic Christmas tree. The kit is by Velleman, and we'll take a quick look at it here. Christmas tree, single-sided PCB, powered off of a 9-volt battery, and then there are some transistors and resistors in there, and a bunch of 3mm LEDs, red LEDs in there, for the lights on the Christmas tree. And the idea is that the LEDs will blink, and that's really all they do. Looking at the schematic here, it is a pair of astable multivibrator circuits, transistor-based ones. These astable multivibrator circuits are a great little intro for electronics, so something to read up on or research on your own. They're very simple. You can build them on a breadboard very easily. 2 transistors, 2 capacitors, 2 resistors here, and then current limiting resistors for the LEDs that you want to turn on. And the way they work is when this bank of LEDs is on, this bank is off, and then when this turns on, this turns off. What controls how long each bank is on or off? It's a combination of the capacitor and the resistor here. For each one, these sort of control the timing. So you can see the capacitors are both 10 microfarads, but the resistors up here are 100K and 82K. So the 100K side will take longer to charge up this capacitor, meaning that this side should stay on longer than this side. So you could vary those capacitors. You could put in different LEDs, and in fact, that's what I want to do. I want to put in different LEDs. But there is a small problem. The problem is the forward voltage of the LEDs. So I want to demonstrate what that is. This is my multimeter. Most multimeters will have a diode mode that lets you measure the forward voltage. And you can see in the top corner there, maybe there's a little diode symbol, so I know that I'm in diode mode. The positive wire goes to the positive lead of the LED, which would be a longer LED lead. There's the negative. And does it light up? Yes, a little bit, just barely. But it shows you that the forward voltage for this red LED is 1.6 volts. Okay, great. What does that mean? That's a fine question. We have a 9-volt battery, and we have 4 of these LEDs here. So add up 4 of those LEDs, 4 times 1.6. That's what, 6.4 volts? So 6.4 of the 9 volts are going to be used up to turn these LEDs on. If we were to put too many more of these LEDs, so if we had 8 LEDs in a row, then it'd be what, 12.8 volts, which is higher than a higher voltage than what the battery can put out. These LEDs would not turn on. What I want to do is I want to put in different LEDs, but the problem is different color LEDs will have different forward voltages. And for example, a blue or a white LED typically has 3 volts forward voltage. So if I put 4 blue LEDs in here, that's 12 volts. That's not enough. It's not going to turn them on. If I put 1 blue one in here and then 3 red ones, would be 4.8 volts plus 3 would be at 7.8 volts. It would just barely work. Other colors, green, yellow, they have different forward voltages. So what I want to do is take a look at my collection of through-hole LEDs that I have. I want to use 5mm LEDs, not these tiny little 3mm ones too. I want to look at those, and I want to see what kind of voltages they are and start making a list of what combinations I could do. There's also this LED or LD9 here. Okay, it's the one at the top. And where is that going to be? Here it is on the schematic. This one I think I want to do something a little special with because it's at the top of the the tree. I might want to use a color changing LED. So I have to assume that as a 3-volt LED. Because it's going to cycle color change between red, green, and blue, and there'll be blue in there. That means I have to treat it as 3 volts. So that means that that's going to probably leave me with the rest of these being reds, which are LD 5, 7, and 11. Let's look at where those are on this tree real quick. How spaced out will that be? LD 7, LD 5. Where is 11? I know you see it, but I don't yet see it. LD 11. So these 4 are going to blink. But that means that would also always blink. And what if I don't want that to blink? That's actually even more interesting. I could cut this trace right here and potentially wire it with its own resistor to the battery contacts. That will be where am I going to solder the batteries to? We can see the outline for where the battery thing is going to be on the back. Oh, there's plus red and black. Okay, so I could wire a resistor from here up to here, and then I could have a constant power supply, cut that trace, have a constant power supply going to LD9, and then I'll just have to make sure. I'm going to have to really modify this PCB because you can see it goes through LD9. I'll have to jumper over that. So I'll have to cut the trace here and here, and I'll have to run a jumper wire across, and then one wire is going to have to go. I'm going to have to do a couple of bodge wires here. All right, that's still doable. And then I can have a little color changing LED at the top. And then I'll only have 3 LEDs over here, which means I have more to play with. I can put a couple of blues in there. I could, in theory, put all 3 blues on there, but I don't think that would work. I think I want like 2 blues and a red, or 2 blues and a yellow maybe, or something. I'll figure that out later. So the next step then is to quickly look at my collection of LEDs and figure out what the forward voltages are for the different colors. So I will get on that now. So I worked out some voltages, and my target forward voltage totals for all 4 LEDs is about 6 volts, because when you get to about 6 volts, the 9-volt battery is considered dead. The problem is I'm probably going to be at like 8 volts or 9 volts even for a lot of this stuff, so I'm not going to be able to get a lot out of the 9-volt battery. My thought is to remove 1 LED from each group up here. So instead of 4 LEDs per, I'll just have 3, and then I'll put a piece of wire linking, bypassing one of these, or replacing one of these with just a little piece of wire, is what I'm trying to say. That way, now if I have like a red, green, and yellow, or even a red, green, and blue, I'm around 6.5 volts. That's good enough for me. I only need to remove 3 because, again, the 4th one, the one at the top here, I'm going to be removing from the circuit and wiring it directly to the battery because it's going to be a color-changing LED. One other thing, this doesn't have an on-off switch, so I want to take care of that real quick. So the way this would normally have worked is you just mount the battery holder like this and screw in a few screws there, and wires come in to red and black as shown, and you solder it on the other side, and away you go. I want to change that. What I'm gonna do is I'm gonna bring the red wire over here, and I'm gonna glue a switch right here, and the wire will just connect to that switch, and you push the button and the wire, and it's just a simple switch here. It's just a little push button job. These you'll see these, or you won't actually, but these are used most commonly in like flashlights, and the button underneath here that turns the flashlight on is going to be one of these, and they're very simple switches. So what I think we're going to do is I'm going to super glue a switch to the side like this, and then, or maybe I'll put it at a slight angle like that. I don't know, I'll have to work that out, but that's the plan. And then once it's in place, you just push that, and what I'll do is I'll bring the red wire over here to one end, and then add another red wire coming out back, and then that'll connect it to the board. So the switch will cut current or cut power to the board and turn it off. That is the plan. That is the switch glued. I'm just going to give it some time for the super glue to cure. But that's going to work. So with the PCB connected like so, you'll be able to just do that to turn it on and off. That should work nicely. So I need to put in the links for the LEDs that I'm removing from the circuit. That I'm replacing them with just a piece of wire. So I'm going to use these scrap leads from capacitors and whatnot of previous projects. And all I'm going to do here is I'm going to use these pliers just as a tool to shape it, like so. And then, for example, LD2, which is right here. Oops. Should go in like that. And then I'll just solder those in place. And that will be one link made, and then I'll have to do that for two more. Do this real quick. Tin my iron tip just so it's a little bit better at transferring all the thermal goodness that it needs to. And then come in with a pair of flush cutters, side cutters, wire cutters, whatever you want to use. Snip the leads off like that, and there is one linked LED. Perfect. So I got to do that for a couple more, and then continue on. In the schematic here we have these resistors, R2, R4, R1, and R3. These are all 1.2K resistors. These limit the current going through the LEDs. Now, because I'm going to be using different color LEDs, the forward voltage all combined is going to be about the same, maybe a little bit higher than what this would have been stock. Also, stock, these resistors would have probably allowed only a couple milliamps through the LEDs. That's fine, but I wouldn't mind having them run a little brighter. So the first thing I came across in my box O resistors are these 820 ohm resistors. So it's about 400 ohms less. Let's take a quick guess at what kind of current. So 9 volts minus the 6 forward volts, or the 6 volts lost from the forward voltage of 3 LEDs that I am thinking of, leaves us with 3 volts. We divide that by the resistance, 820 ohms. And this is going to run now at about 3.5 volts, whereas 3.5 milliamps, whereas before it would have been 2.5 milliamps. So we're gaining a whole milliamp by making this little swap here with the resistor. So I'm going to put those in, as well as R6, R8, R5, and R7. Now these, of course, control how quickly these blink on and off. Do I want to add in or change those as well? Maybe find like a 47K or a 60K or something else, something close by but different, because I want this to turn on and then I want the blinking to be between these two. I don't want them to blink in sync. I want them to blink differently, and I want it to just have a different pattern. So I might change those, but I might not. I might just leave it because I'm feeling kind of lazy at this point. We'll see. So those four LED current limiting resistors, the 820 ohms, those are all in. Now here are four more resistors. What I've done is the original schematic had two 82Ks and two 100K resistors. I have removed one of the 100K resistors and put a 75K resistor in, and now I'm just going to mix them all up like so, and I'll just put them in randomly and without any real thought as to, you know, how they're paired up. So that way the blinking will be fairly random, instead of me trying to put some thought into, well, after so many minutes this will sync up with this, and won't that look... No, don't worry about that. Let's just put it in at random. And oh, well, you know what? I can't stop that. I've done it. I can see that I've put... Are those both 100K resistors in the same spot? R7 and R5. Let's just make sure R7 and R5 are not on the same thing. They aren't. They are, aren't they? Yeah. So one side's going to have an even blink the whole time. You know what? No, we'll stick with it. I said I would just put them in at random and where, you know, let the chips fall where they may, as it were. So tough. There will be even blinking on that set of LEDs. So I'll solder these up and then figure out what the heck I'm going to do next. Next up is going to be the LEDs. And the way I think I'm going to handle this is sort of like I did with the resistors. I'm just going to pop them in at random locations, knowing that LED 9 up here at the top I'm leaving empty because I've got to modify that. But I'm not going to worry about modifying it right this second. What I'm going to do in terms of LEDs here is I've got 3 of each color, red, green, and yellow. I'm not going to do blue. I just figured I won't. It's going to make life easier. And it also means that I can just poke these in at random. I have a couple 3mm LEDs in here as well, just for some visual difference. So the plan here now is to just put these things in at random, spread them out, make them, you know, look like they have some order to them, but not too much. In fact, what I'll probably do here is I'll put the 3mm in first. The reason being that they're shorter than the 5mm LEDs, so when I go to solder these, when I flip the board over, I want the tallest component being the one that I'm soldering, so when I press it down into the bench here, it'll hold it in place. It'll be pressing against the tallest components that I'm soldering in. That's the plan anyways. Where does that one want to go? I think it wants to go here. LEDs are polarized, meaning there's a plus side and a minus side. There's only one way they can go in. The longer lead is the positive side. And if you look at the image or the outline of the LED on the board here, you can see that there's a flat edge that represents the negative side. So the long lead needs to go into the hole opposite the flat edge of the silkscreen marking for the LED, like that. But we'll get to that later. So I'm going to flip this over now, like so, and I will solder those in. I'll just do one leg, and then flip it back over, and well, I'll show you in a second. Alright, so one leg of each is soldered in, but you can see especially this one is at an odd angle, and that's the reason I only did one leg at a time, because now I can come in and reflow the solder joint there while pushing with my finger to straighten out and get the LED up against the PCB. And that doesn't want to go up any further because it looks like the plastic that was used to go around the LED, the red plastic, has dripped down onto the leads a little bit, so there is... I can't put it flat against the PCB. I just have to try and make it as straight as possible. That'll work. The rest of these are probably going to be fine. That's just one LED that has a little manufacturing defect to it. Not a big deal. Should not impact its functionality. Alright. Those are also the LEDs that came out of the kit, these two little red ones that have the weird issue with it not being able to go flat against the PCB, whereas the others, which I bought off of eBay in bulk, are fine. Alright, so now I can solder the rest of them in, then do the big ones, and we'll go from there. Alright, so all the LEDs are in except for the special one at the top, because I haven't made that modification yet. The first step will be to bypass that LED. So essentially, we see that it is LD9. If we look on the schematic here, basically what I want to do is I want to create a jumper wire that comes down here like this and goes around where LD9 is, and then I'll cut the trace here so LD9 is isolated, and then I can run wires to just that LED from the power supply. So looking on the back of the PCB here, this is LED9 or LD9, and we can follow that trace all the way down to here. So here, the pin that I haven't cut yet is where we're going to bypass LED9, and then we follow, it comes through here, up, down through here, and we can see that this is the other side of the bypass that we're going to make here. So these two LED leads that I haven't cut yet are what I'm going to use to jumper over it. I'm going to sort of bend them against the PCB like this. Oops, like that. There we go. And then this can come up. I'm going to have to shape it out and around because I've got that LED there. And maybe I do something like that. Then put a little bit of solder there to make the connection, and then I could snip the excess off. In fact, I should probably snip the excess before I do this. So I'll just come in here with my side cutters, cut that off like so, and then try and shape this a little bit better. There. That should make a connection, focus, between the two sides there, and I can quickly, well, I say quickly, I can check that real quick with my multimeter here. I'm going to put it on continuity, which means it's going to beep if the two probes are connected. There. Okay, so here are my probes, and if they touch, it makes a beep. So if I connect here and here, good connection. So we have bypassed that LED. So the next step now is to complete that mod. I need to cut the traces. I can cut them anywhere I want here, but probably here and here. Probably like around here and here, probably the best place to cut. And then I can run wires from either scrape off the solder mask here and run wires down to the power supply at the bottom, or tack them onto the leads that'll be coming out of here. Lots of options. So just so you can see, I have used a hobby knife to cut a little sliver of the copper trace off of the PCB. This LED is now removed from the circuit. So I need to put the LED in there and run a couple wires down to where the battery pack will connect. I'll worry about that a little later. I've skipped ahead a little bit here, and I've realized that I should have put the capacitors in before I put in the tall LEDs, just because they're going to show or be a little bit higher, or a little bit shorter, I should say, off of the PCB than the big LEDs, but oh well. On the back here, I have taken one of the 1.2K resistors originally intended for the group of LEDs and the schematic, one of these, and I've put that in line with the color changing LED. That should limit it to about between 5 to 7 milliamps. So it's going to be a little bit brighter than the other LEDs, but that should be fine. And I've got a red wire for the positive side, a black wire with the connected to the resistor going off down here. I'll hook those up a little bit later. I have used the resistors ceramic, or is that plastic or epoxy? I don't know. The body of the resistor as like an insulator from the, and I'm resting it across that jumper across the middle there. That's how it's going to be in its final form. I will put heat shrink tubing over that, but for now that looks okay. So I'm going to finish putting in the capacitors and the transistors, and then we'll be pretty close to done. I'll show you what one of the capacitors, what putting these in is like. So I have a positive and a negative. These are polarized just like the LEDs. The negative, or the short wire, is the negative wire you can see here. It also is marked on the capacitor. That is the negative side. And what I need to do here is bend these leads 90 degrees. So I want to first figure out the orientation. Positive on the left, negative on the right. Bend it like so. And just drop it in and then solder it, and away you go. I treat these like LEDs too. I'll just solder the one lead, and then I'll come back and readjust it so it's flat against the PCB before I solder the second lead. The transistors, well, I'll cover those in a minute. I didn't film this part just because it was a pain in the butt to wire up, but there it is. There's the wire cut, soldered to that tab, and a little bit of heat shrink just to, hide that from something. I don't know what. So I just need another wire coming off of this end, and it'll come back down here where it'll flip onto the PCB, and that will give me an on-off switch. So there's the wires all put together to the switch. The tape is there just to hold the wires in place, so that way they hopefully don't get mashed when I put the battery holder to the PCB. I did a quick test fit here, sort of like that, just to see where all the wires go. And it's kind of close, but I think we'll be okay. It should be fine. So the next step now is I need to run these wires, the black and the red wires, down through here. I'm just going to tape them in place with maybe some Captain tape or more of that red electrical tape, just so everything is lined up, and also I know that the wires are going to be flat against the PCB when I put that battery holder on. I'll probably run them both over the side where the negative wire is, because I know there's not going to be any wires here. And then down here I'll just cut the red one over here like that. The black one will go there. No problem. I don't know why initially I was thinking that I needed to run the wires for that LED all the way down here to the the battery contacts because you can follow the traces and they go all the way up on either side. So I found a new place to connect the negative wire and a new place for the positive wire to the color changing LED that's going to be at the top there. The 1.2K resistor with some heat shrink wrapped around it. So all that's left now is to wire up the battery pack here, and we're ready to try it out. Alright, we are about ready to try this out. There is, the wires are soldered in. I'm just going to put them in like that, and then we have 3 screws here. And they're going to create threads into the plastic body of these 3 screw holes on this thing here. I want to make sure that when I screw this in place that I make good threads, so I'm going to use a big screwdriver here so I can get a lot of torque on those screws. I'm not going to go all the way in just yet because I want to make sure this is lined up. Looking good, looking good. Alright. So now all that's left is to find a 9-volt battery, which I've got one right here. There we go. All the LEDs are lighting up, including the color changing one at the top. I feel like 100K may have actually been too low, and I probably should have, instead of putting a 75K in there, maybe I should have gone with something like a 120 or 140K or something like that. Just so that the blinking was a little bit slower. But you can see it does get into odd patterns, like where it looks like it's sort of, I don't know, turning out, and then how it's switching between the bottom and the top, and then they start to go out of sync again. Yeah, that came out pretty good. I'm okay with how that works. I think all the LEDs look good. I like the different sizes. I like putting the color changing LED up at the top there as sort of like the star on top of the tree. I'll try the button. The button works as it should. I think I'm real happy with how that came out. Now I just have to wait for Christmas.